So we have a postdoc. We're trying to generate postdocs here at the Royal College of Art. We're not very good at beyond the doctoral level of research, of maintaining doctoral students into postdoc research. And so Sergio Cabrero is a postdoc at CWI. And although I tried to persuade him to talk about how the postdoc research related to the doctoral, it doesn't, so he won't. But he's here as a living example of how enlightened organizations, especially those that receive 70% of their funding from the state and only have to seek 30% of their funding from other sources, can then generate forms of research that are both academic but also non-academic, that link different kinds of organizational methods and methodologies. So this is the Smart Wearable Textiles and the Amsterdam dance event, and we'll let Sergio explain.
Okay. Does it work? Yeah? Okay. So I can explain a bit how I became a postdoc in this area now, but because the research is not directly related, but there are parts of my previous research that are reflected here. So I did a PhD in multimedia over wireless SADOT networks. And in these experiments we are doing in the group, as Pablo showed, we build real systems that need all the parts. So now I'm working more in not only how to make the signals from sensors go into the right places, but also how to interpret that. But for that, we also need to create the right networks and the right adaptive systems. So we can say that it's an evolution more than a real change. So before, I thought that it might not be necessary to explain what the Amsterdam Dance Event is, but who knows what the Amsterdam Dance Event is, because it's not really about dancing in the classical sense, but it's an electronic music festival. I think it's like the biggest electronic music festival, at least in Europe. So I'm not gonna talk about dancers. I'm gonna talk about party, and as Pablo said, we like to party a lot, so we we went to a party to do experiments as well. So this was October 2016. We got invited by Borre, who curated a party for Red Bull during the Amsterdam Dance Event. It was a 2-night party. We had almost 1,000 guests. We gave wristbands to people with sensors. We monitored them, and we tried to share that data back in forms of experiences. And in the talk now, I'm going to walk you through the different aspects of the party. I'm going to walk you through how we gather the data, how we process this data to get meaningful insights, and how do we use these insights to create different types of experiences around the party. And the last thing I'm going to tell is about our future plans in this direction with our new project called Project Cairo. So the party. I think the best thing to explain the party is let Borre himself explain it in a short video.
If you ask me what the future is going to look like, there are no borders. There are no distances. Technology actually brings everything together. All of your senses are heightened when being fully in the moment, enjoying and being aware of your surroundings. And that is what I want to create.
Yeah, so this was exploring the club of the future. You might have recognized some of our old sensors from sensing audiences there, also seen the wristbands. One of the mottos was party like it's 2019, right? And some statistics or numbers around the party. It was 2 nights, around 7 hours per night. Approximately 500 guests. It was 2 nights, so it was Thursday and Friday. We have few less people on Thursday and a few more on Friday. Everybody was a VIP. It's difficult to understand the concept, but everybody was a VIP. But then we had between 60 and 75 guests each night that were even more VIP, which were the friends of Red Bull, and they enjoyed the party, and also a Michelin star dinner with a nice chef from Amsterdam. There were 2 dance floors, a chill-out room that was called the Overdrive Room, several bars. Of course, selected artists and DJs because this was the Amsterdam Dance event. So it's a really important party, actually. And it's really important for brands to really convince the people around them and the clients and influencers to promote them. And it took place in an iconic building in Amsterdam that is just next to Dam Square, that is called the Baggenhuis. And the floor plan looks something like that. So it was just 1 floor. It was not a very big space. As Borja said, when you excite all your senses, you become fully aware of the moment, right? So that was another mode of the party. It was around 5 senses. So there was a perfume designer, there were light artists, interior designers, there was the Michelin star chef, there were DJs, but there was also a 4D sound system that guide people through the different rooms. And of course, there was the touching forum of textiles that Borja created for different objects, not only clothes, but also sofas and such. So our role there as a technology partner in the project was to be able to use technology and sensor technology to capture these different experiences and individual and crowd experiences, and to be able to share that back during the party and afterwards. And what we did is sharing that back for the guests of the party, but it might also be that at some point in events like this, we want to share it back to the organizer of the party or the DJ, like Pablo explained for theater directors and such. So this was the challenge, and the challenge of capturing the experiences started asking ourselves, how do we make people forget about being tracked? Because the idea was that people had to be fully aware of the moment. So we didn't want them to install a telephone app that you could track them or get data from them. It's also, you need some more actions from their part. We didn't want to give them techie objects or sensors that were very obvious, because they can become distracted by the technology. So no surprise, talking here, we opt for doing something with textiles. And all of you, or many of you, know a lot more about textile manufacturing than I do, but I'm going to try to explain a bit of how is the signature process that Borja does to create their textiles. So what they inspired in the way you do mattresses. So they use a special weaving and a circular knitting, so they can do 3D textile knitting. And what is very important, at least for us, is that they can be very precise when they design things. So I have some fabrics here. So they can be very precise. They can create the right holes, and they can put conductive yarns. So we can embed technology very, very easily in what they do, right? So for this party, no surprise, we went for a sensor textile integration in the form of a Bluetooth low energy enabled wristbands. So we had 2 types of wristbands for the VIP, which were not that VIP. We had this model. We made 900 of these. They had a sensor that is the Estimote sticker that is impossible to see from there, I guess, but I will pass it around. It's very small. It goes here. They left the right hole here, so you cannot really notice that you have a sensor inside, right? So maybe take a look. These sensors give you temperature and accelerometer data. That means when you move your hand, you can see that movement. And they give that data every 1 second or 2 seconds approximately. Then for the more, the friends of Red Bull, the more real VIP guys, we had some wristbands that were a bit more special, and that came in a very nice, box in the form of invitation. And they have a leather strap, and what they have inside is this sensor that is called the sensor tag, Textiles instrument sensor tag, that is a bit more expensive than the Estimote, so that's why we had less of them. You have to program it yourself. That means that you can do a lot of things with them. We program it to make the same things as the Estimote does, but also we also solder some lights here, so we connect to the sensor and make the LEDs light up, and you could see that through the wristband. You can also pass this, maybe not. You counted them. Yeah, sure. So this was the way that we capture data from people, and when we try to capture the experience. But of course, we had a big problem, as you can imagine, is that once you put 500 people in a relatively small space, in a dance floor, and they all have devices with them, and these are Bluetooth devices, that means that also your phones are sending Bluetooth messages, and they all share the same frequency, and believe me, that can be a mess to get the data. So how do we make the club listen to this data that came from the crowd? What we construct was we designed a network of Raspberry Pis. So this is the flow map, and each of these icons is a Raspberry Pi. We put around 24 of them in the space, and we put them in strategic locations so we could gather as much data as possible. And we knew that gathering all the data in this situation is impossible because real systems work like that. So we try to maximize this. So now we assume that we have everybody with the wristband. We have our Raspberry Pis that get the data, but we just have some temperature data, some accelerometer that are just numbers. How do we go from this to real insights that we can transform in experiences? So we on getting individual and crowd insights of 3 things. We focus on temperature. So that was straightforward from the sensor. We could get the temperature that each wristband was measuring, and then we could see the temperature of the room. We focus also on location. Indoor location, it's quite possible when you have one person in one room, because you can do also all kinds of signal processing, you can do triangulation, but once you have 200 people in a dance floor, that becomes much, much more difficult. So we didn't go for precise indoor location, but we tried to guess in which room you were, which is not that easy in this environment. That's the number of Raspberry Pis we have to put in the space also to be able to differentiate in which room you were. And finally, we also try to get the energy level of each person in the crowd. And what we meant by energy level is basically trying to see if you are dancing, right? This is a dance party, so we try to see if you are dancing. This is an activity recognition problem, which is, well, in many places now in research. But dancing is not an exercise activity, so we have these fit bands that tell us when we run, when we do weight training, or when we swim. We have our phones that tell us how long we walk today. But dancing is not that developed. So what did we have to do, right? We had to train the system ourselves. So we had some mock-ups of the wristbands, which are, of course, not the nice wristbands, and that's the team dancing in the lab. And, well, we use this, then dancing in the party looked probably not like this, but that's okay. There was another problem with, I'm gonna just leave this video because I think you like it. So not recognizing dancing was not the only problem, but there were other problems related with how the system works, right? First, we have sensors that might not get all the information through because we have too many of them, and they don't give us data with a high frequency. Normally, activity recognition works better with a higher frequency, right? So what we needed to do is we needed to create a system appropriate for that, and you can just laugh again because there we are, just with 2 or 4 boxes of 900 sensors, shaking them because when you shake the ST modes, they broadcast at the highest speed possible, that is about a second. So we tried to see, well, if we have 900 sensors together, what is the worst case, how many packets we get, so how much data makes it through, right? So we use these experiments in the lab to train a neural network. A neural network is just an artificial intelligence technique in which you put the data in from your wristbands. This is the accelerometer data. And you train it to recognize something. And you get an output of the activity you recognize. In this case, we got an output of 3 energy levels. So it's low energy, that is basically that you're standing. Medium energy, that you're probably walking, going to the bar, going to the dinner. And high energy, that we hope that is because you're dancing and having fun in the party. By the way, in the party, this had different names like taking off and flying because it was, of course, a Red Bull party. So all in all, this was the data pipeline in a whole. We have sensors. We had a network of Raspberry Pis. All of this was aggregated into a central server. And from that server, we run different activity recognition, location, temperature processes. And this was an output to other systems in the party. But by the way, just a small, more techie break. There is an open data set with the Bluetooth packets and the sensor data in case someone is interested. This is in the GitHub account of the group. And there we have like 40 million Bluetooth low energy packets from the 2 nights with some metadata about these packets. And in 40 million of these packets, there were also sensor readings. So we had also the readings from individual persons. And by the way, this is, of course, completely anonymous. So at this point, with this data, we don't know who was wearing the wristband. We just know that somebody was wearing a wristband in the party, and this happened, which is also an important part. So last but not least, because this is the fancier part, is, well, you get these insights and how you create experiences from them. There were different types of experiences that I'm going to show here. Some of them happen in during the party. So this was the overdrive room. This was a very experimental room with some lighting. It was normally darker than this. This was during the testing. And the idea of this room is that this is a room you go to chill out. So when the main dance floor is in a high energy level, let's call it. Everybody dancing. This room was very calm, and the other way around. So how do we manage that? Is we got the energy level in the main dance floor, and fed that into the sound system of the room, and then the sound experts create more calm sound from that. Another experience during the party was the visualizations. So there were live visualizations where you had a nickname. You asked, every time you gave a wristband to somebody, you asked for a nickname, and this nickname was displayed in the visualization. They were displayed randomly or after some events. So you had the room in which this guy was. So Valtteri was in the overdrive room. You also got some statistics of the room, like the temperature of the room, the number of people in the party, and the number of people in different energy levels. After the party, every VIP guest receive no VIP. Oh, yeah, every VIP. So basically, every guest receive, but VIP sounds better. Receives a printout like this, in which one side is the crowd. This represents a night, the whole night. So you have energy, that is the amplitude of the shape you see there. The color is the room, so that means, so the purple is the main dance floor, dance floor thing. So you see how people went from one place to the other, and you see their activity level. And then you could also see the most active moments of the highest energy moments in the party, and how that was, like, for instance, Venus X, that was a DJ in the Black Boss, that was like the second dance floor, right? And if you turn it around, what you have is your individual flight of the night. So this is a different shape, in which, starting from the bottom, you have the beginning of the night, and the end is the top. And the amplitude, again, is the activity, but this is your own personal energy level, your activity level, and the color is the room in which we saw you during the party. So I can. So for the Friends of Red Bull, the super VIPs, there was that, and there was this scarf that is an example of an object, fashion object created from data, right? So we got your personal data, and Byborg transformed it into a knitting pattern that is personal and individualized for every friend of Red Bull that assisted to the party. So these are examples of how you get data from people and use it during the event, and you also use it after the event, so they probably will remember about this Amsterdam Dance Event edition for a long time, which is good for Byborg, good for Red Bull, good for us. So question is, what now, right? We like very much this project. I like very much this project. That probably might shift from more systems perspective to a more sensor human-computer interaction perspective. So we decided to keep collaborating, and we asked for a very small project. This is a nice research grant from the Dutch government that gives you some money to create some initial steps with a company in a new direction that is interesting for the company, that has a research aspect on it. And we are collaborating with Byborg. It's about making an intelligent soft robotic jacket. And it's soft robotic because we are very honored and lucky to have Amolf with us, which is Amolf is a molecular physics institute in the Netherlands, And specific, we have the soft robotic matter group with Buzz. And, well, I don't dare explaining what soft robots are here, but after seeing it, but this is the kind of things that Buzz is doing. Is this playing? Yeah. So he has these soft robots and origami style structures in which you can actuate them with pressure, and they will change from one state to another, basically exploiting non-linearity properties and complex systems and stuff like that. So the idea is that we will use our experiences in getting data and putting sensors in wearables and connecting that in architectures like Jotza and Igor with also external sensors, for instance, sensors that can be on your bike. Merge that with data sources like weather prediction and things like that, and use your user profile to create wearables that not only sense you, but are also reactive, and they can change their physical properties according to all this data and to your personal preferences. And to make them reactive, we want to use this, or we want to explore these soft robots origami materials embedded in the textiles, as we have done so far with the sensors. So the results will hopefully be a personalized intelligent bike that, for instance, something that in Amsterdam is very important is that when you leave your house and you take your bike to go to work, either you freeze at the beginning or you boil at the end, because you have to cycle a lot, and it normally rains and it's very cold or windy, or just the other way around, because it might rain when you start cycling and be sunny when you end and you leave 20 minutes from work. So having a jacket that can adapt these kind of things for yourself, and for example open vents or create isolation on demand, not just because an external reaction, but because it's something that makes sense for yourself and for the data that is being gathered. So that's all from my part. Yeah, thanks to many people that was involved in the project, and if you have any questions, contact me or just take it offline.